Welcome to This Explainer. Today, we're diving into the thrilling and, honestly, kind of unbelievable story behind the invisible infrastructure that literally powers our daily lives. You know, we take it totally for granted every single time we check our phones, but the origin of GPS? It's this wild web of history, physics, and totally accidental discovery. Let's get right into it.
To really appreciate what we're talking about here, just think for a second about the actual sci-fi reality sitting right there in your pocket. Right this very second, your phone knows exactly where you are on the planet, down to just a few meters. And how on earth does it pull that off? By having this silent, continuous conversation with a network of satellites flying 20,000 kilometers right above your head. I mean, it sounds like something straight out of a futuristic movie, right?
But here's the real kicker. This modern miracle, it wasn't cooked up in some sleek tech hub in Silicon Valley. No way. It was actually born out of profound geopolitical anxiety. We're not talking about a trendy app or a startup here. It literally all started with a simple, kind of haunting beeping sound right in the middle of a massive Cold War panic.
So, Part 1, the Cold War Spark. The date is October 4th, 1957, and the Soviet Union has just launched Sputnik, a beach ball-sized metal sphere, sending absolute shockwaves across the globe.
Now, while the rest of the world was panicking, two curious physicists over at Johns Hopkins University decided to just, well, listen in. They tuned in to Sputnik's radio signal, just out of pure curiosity, and they noticed this distinct pattern. The pitch of the beep actually rose as it got closer to them, and then dropped as it moved away. If that sounds familiar, it's because it's the Doppler effect. It's the exact same physics you hear when an ambulance siren speeds past you on the street.
And here is where the real breakthrough happens. These guys realized that by analyzing that specific pitch shift over time, they could calculate the satellite's exact orbit from the ground. And they were doing this using absolutely nothing but that shifting radio signal. It was incredible. They had essentially figured out a way to map the exact path of an object moving through space.
Which brings us right to Section 2, flipping the concept. The scientist boss, a guy named Frank McClure, took a look at what they had accidentally discovered, and he did something brilliant. He completely inverted the science.
McClure basically asked this simple, upside-down question. Okay, if we can figure out exactly where a satellite is in space from a known point down here on Earth, couldn't we find our exact location on Earth by using known satellites up in space? And that single flipped thought, it absolutely changed human navigation forever.
The very first answer to that question was the Navy's transit system back in 1960. It was built specifically for stationary nuclear submarines because those subs really needed to know their exact position before, a missile launch. And sure, it worked, but getting just a single location fix took over an hour. So, by the early 1970s, the military was demanding a major upgrade. They needed a system that was lightning fast, highly mobile, and universally usable by moving vehicles, whether they were on land, at sea, or in the air.
All right, Section 3, Project NAVSTAR. So this huge military demand was finally tackled during a famously intense Labor Day weekend meeting at the Pentagon back in 1973. The military had all these different factions pushing their own competing tech, and they desperately needed to get everyone on the exact same page.
And they actually pulled it off, thanks to three key figures. First, you had Roger Easton, who proposed this vital idea of outfitting satellites with highly synchronized atomic clocks. Then there was Ivan Getting, who pushed really hard for a system that moving vehicles could actually use in real time. And finally, Air Force Colonel Bradford Parkinson. He was the one who managed to merge all these rival ideas into one unified plan, which they called Project NAVSTAR. Today, of course, the world knows it simply as GPS.
Let's move on to Section 4, the physics of location. Let's actually look at how GPS works under the hood, because the underlying science makes this whole system feel even more magical.
Like Roger Easton proposed, the entire system completely hinges on time. Every single GPS satellite out there carries an atomic clock. And we're not talking about your standard wristwatch here. These aren't just accurate to the second, they're accurate to within nanoseconds. As they're orbiting the Earth, these satellites are constantly shouting out two key pieces of info: their exact position in space and the exact, down to the nanosecond time that they broadcast the message.
So how does your phone actually figure out where it is? Well, your device receives these broadcast signals from at least 4 different satellites. And because radio waves travel at a constant rate, the speed of light, your phone can measure exactly how long each signal took to arrive all the way from space. Then it mathematically converts that travel time into a precise distance. Once it has the exact distances from 4 different satellites, your phone essentially triangulates itself. The intersection of those 4 signals reveals your precise 3D position, plus the exact time. And it does all of this insane math in just a matter of seconds. Pretty wild, right?
This brings us to Section 5, from tragedy to everyday use. For years, this brilliant technology was strictly locked away as military hardware. But then, a truly awful event caused a massive global shift in policy.
In 1983, a commercial flight, a Korean passenger jet, accidentally strayed off course right into Soviet airspace. Tragically, the plane was shot down, and it claimed the lives of every single person on board. When they investigated, it turned out that a simple navigation error was actually the root cause of the entire disaster. In direct response to that devastating loss of life, President Ronald Reagan made a landmark announcement. He declared that once the military's GPS constellation was fully complete, this technology would no longer be locked away behind closed doors. It was going to be made available for civilian use, worldwide, completely free of charge. And that right there was the pivotal decision that quietly altered the course of everyday life forever.
Looking back at this sweeping historical journey, you can really trace the entire arc. We go from a Cold War curiosity sparked by Sputnik in 1957 to those slow Navy systems of the 60s, the NAVSTAR unification in '73, and then the very first launch in 1978. Reagan's authorization in 1983 ultimately paved the way to 1993, which is when a fully operational constellation of 24 satellites was finally up there, orbiting the globe.
Throughout the 90s and 2000s, this massive pivot meant that GPS moved way beyond just military hardware. It found its way into our cars, global shipping logistics, commercial flight paths, and eventually, right into the smartphone you carry around every single day. I mean, we use it billions of times a day for driving directions, for disaster response, and even for scientific breakthroughs we couldn't have possibly imagined back in 1957.
So the next time your map app finds your location in mere seconds, I really want you to remember this deeply human, incredibly complicated history. As our source material so perfectly puts it, it took a Cold War, a sunk ship's warning, and a room full of stubborn engineers to make that possible.
And that leaves us with this final, truly fascinating thought to chew on. If just casually eavesdropping on a beeping Soviet satellite could completely revolutionize human navigation forever, what other accidental scientific discoveries are happening in labs right now as we speak? What weird anomalies are scientists scratching their heads at today that are going to quietly become the invisible miracles of our everyday lives in the future? Thank you so much for exploring this explainer with me today. Keep wondering and keep looking up.